Hello friends, I Prof.Darshan Thakur from Terna Engineering College Dharashiv welcomes you on my YouTube channel for this subject head Network Theory. So friends, as far as our today's session is concerned, so we will try to learn one more example based on this technique whose name is nothing but what? The nodal analysis. In that previous session we had described the introductory part of this nodal analysis. So if you are having any doubt regarding this nodal analysis, so I will give you the link for that lecture, so you just go through that, right? So again, as far as our today's session is concerned, so our objective is to determine, as you can see, such type of DC network we are having with us. A network means finite number of elements we are having with us in terms of RLC and the energy sources, right? Now currently this is the pure DC network. We don't have any energy storing devices which are mentioned within this network. So there are only resistors along with these energy sources, right? Now as far as these energy sources are concerned, so as I told you earlier, we are having dependent and independent energy sources. So far we had not discussed any numericals based upon this dependent energy source. So probably in forthcoming session we will try to discuss the numericals in which we are having the dependent energy sources. So currently in this network we are having two independent sources, right? One is nothing but what, the current source of 1 ampere and the voltage source of 20 volt. So in case of this nodal analysis, one thing which we need to understand, most of the time this nodal analysis is being preferred over the mesh analysis, because we can reduce the number of equations which are to be written for that existing network, right? So similarly, from loop analysis or the mesh analysis point of view, if we are going to analyze this given network, so at that time we will come to know that there are 4 different loops or 4 different mesh we are having. So 4 different equations we need to write. So there are 4 different unknown variable we used to have with us. Then with the help of that calculator we need to solve, which was quite a complicated process, right? So in order to minimize the complexity of that circuit analysis, from nodal analysis point of view, undoubtedly we are using the Kirchhoff current law, similar to that Kirchhoff voltage law, which was adopted by the loop analysis or the mesh analysis. In case of this nodal analysis, we are supposed to use the basic logic behind this Kirchhoff current law, which says that the summation of, or the algebraic sum of incoming current plus algebraic sum of outgoing current equals to 0, or the algebraic sum of incoming current equals to algebraic sum of outgoing current. So at that particular nodes we need to apply this Kirchhoff current law. So the most important thing from nodal analysis point of view, in case of this given network, is to identify how many number of nodes we are having with us, right? So node or junction is nothing but what? The point at which multiple number of branches are interconnected to each other, right? For sake of our understanding, carefully just try to see the lower end of each and every branch. This is the first, second, third, fourth and fifth branch, right? The lower end of these all 5 branches are associated with the same potential. That is nothing but what? The 0 volt. So this node can be called it as a ground node. Am I right? That can be called it as a ground node. And our objective is to determine the current flowing through this 5 ohm resistor. Here I will write. That will be our objective for today's session, right? So this node is nothing but what? The point at which multiple number of branches are interconnected with each other. Similar to that, from sake of observation, we need to observe to that upper terminal how many nodes we are having with us, right? Like see, at this particular point, this branch is associated, or the upper terminal of that branch is incorporated at that particular point. Again, the upper terminal of this branch is also associated with that same point. The adjacent terminal of this 5 ohm resistor is also placed at the same potential. So this potential or this equipotential or the same potential, the point at which 3 branches are associated with each other, that can be called it as a node. That is nothing but what? Node number 1, whose potential is nothing but what? V suffix A. So in this way, this will be the first node whose potential is nothing but what? VA. In same manner, one more node we are having with us at this point. This branch is also connected, this is also connected, and this third branch is also connected. So the potential which is present at this branch, that can be called it as a VB. And one more node we used to have with us, whose potential is nothing but what, VC. Because see, this branch is also associated with this node. The low upper terminal of this branch is also terminated at this potential. The negative plate of this 20 volt battery is also terminated at that same potential. So that's why we are having totally 3 nodes along with this ground node, right? So what we need to do next, once these nodes are being identified, we need to map these 3 nodes with their potentials. So VA, VB and VC. Then immediately after that we need to apply this KCL at VA, VB and VC. So initially when we apply this Kirchhoff current law to this node potential VA, so at this node there are 3 branches which are being interconnected to each other. So at the same time we need to assume the direction of these 3 branch currents, right? So this is the first branch. In that first branch we are having this current self of 1 ampere, and what this arrow indicate, the natural direction of that current is nothing but what, incoming towards that node. But while considering this current, its direction can be assumed as outgoing. So this will be I1, this will be I2, again it is outgoing, and this will be I3. So I1, I2 and I3, these 3 are the branch currents associated with this node potential VA. According to this Kirchhoff current law, summation of incoming plus outgoing equals to 0. Here we don't have any incoming currents. All the currents are to be assumed as outgoing, right? But here one twist is there, in that first branch we are having only one current source. Along with this current source we don't have any resistive branch or resistive element which is associated with that branch. So I1 itself is a 1 ampere, but the direction of this current source is incoming. How it is to be considered? Outgoing. So first of all we need to write the current equation at this node. So current equation at this node VA will become what? I1 plus I2 plus I3 equals to 0, right? Now I1 is nothing but what? The current belongs to that first branch. It is considered as outgoing, but it is incoming. That's why we need to consider the negative sign, -1, right? What about this I2? I2 is nothing but what? The current flowing through this 2 ohm of resistor. How it is connected? Like this. This is ground node, this is VA, and this is 2 ohm of resistor. So according to that Ohm's law, I equals to V by R, right? So which potential we need to consider? VA divided by 2. What about this I3? I3 is nothing but current flowing through this 5 ohm of resistor. It is connected in this horizontal arm like this. Here VA, VB, and this resistor is of 5 ohm, right? When we are applying the Kirchhoff current law at that first node, so at that time the significance of VA is greater than VB, obviously. How the current is being considered? Outgoing, right? So the current equation will become what? V by R. V in the sense the difference in between these 2 voltages, VA minus VB divided by 5 equals to 0. Okay. Then after that, simply some mathematical simplification we need to do. This -1 is being shifted to the right hand side of this operator. At the same time, which term is preferable for taking LCM? 2, 5 to the 10. So this 10 can be considered as a LCM, right? So it will become 2 5s are 10, 5 times of VA plus 5 2s are 10, 2 VA minus 2 VB equals to -1 plus whole term will become equals to 0. I am keeping this -1 as it is initially because first this 10 will get multiplied with this 0. So our equation will become what here? 5VA plus 2VA, it will become 7. 7 times of VA minus 2 times of VB equals to this 10 into 0, 0, and at the same time -1 is being shifted to the right hand side, so plus 1. This is our equation number 1. When we apply KCL at node number 1. In same manner, when we apply the KCL at node number 2, whose potential is nothing but what? VB, right? So at this node also there are three adjacent branches which are being connected or associated with this node. So their directions we need to consider as outgoing. So this will be I3, right? This will be I4 and this will be I5, right? So I3 is outgoing from this VB, I4 is also outgoing from this VB, and I5 is also outgoing from this VB. So when we apply KCL at node 2 whose potential is nothing but what? VB, so the current equation will become what? I3 plus I4 plus I5 equals to 0, because according to this Kirchhoff current law, summation of incoming current plus outgoing currents equals to 0, or incoming equals to outgoing, right? So I3 is nothing but what? Current flowing through this 5 ohm of resistor, right? How it is being considered now? It is being considered as outgoing from this VB. When that KCL is being applied from node number 2, so VB is greater than VA. So as a result of this, according to that Ohm's law, I3 equals to what? VB minus VA divided by 5. Okay. What about this I4? I4 is nothing but what? Current flowing through this 20 ohm of resistor. Here instead of 2, here I will write as a 20, and this is nothing but what? Potential VB, and this is nothing but what? The ground node. So I equals to V by R, right? So I4, how it is being considered? Outgoing. So I4, here I will write I4 equals to VB by 20, right? What about this I5? I5 is nothing but what? The current flowing through this 4 ohm of resistor, which is connected in between this VB and VC. As this VB is greater than VC, so according to that Ohm's law, I5 equals to what? VB minus VC upon 4, right? So in this way, I3, I4 and I5 are to be defined. So one by one we need to write. I3 equals to what? VB minus VA divided by 5. Here I will write VB minus VA divided by 5 plus I4 is nothing but current flowing through this 20 ohm of resistor, VB by 20, plus I5 current flowing through this 4 ohm of resistor, VB minus VC, VB minus VC upon 4 equals to 0. Okay. Then here also LCM can be considered as a 20. Here I will write, if LCM is 20, then 5 4s are 20, 4 VB, 5 4s are 20 minus 4 VA plus VB, 20 by 20 plus VB plus 4 5s are 20, means 5 VB minus 4 VC equals to 0, right? So our equation will become what? This 20 will get multiplied with this 0. So equation will become 4 times of VB minus 4 times of VA plus VB plus 5 VB minus 4 VC equals to 0, right? So finally our equation here I will write minus 4 times of VA in ascending order. How many terms we are having belongs to VB? 4 plus 1 5, 5 plus 5 10. So it will become minus 4 VA plus 10 VB minus 4 VC equals to 0, right? This is equation number 2 when we apply this KCL at node number 2, right? Now another interesting thing about this numerical key, as far as this node number 3 is concerned, whose potential is nothing but what? VC, right? So when we apply KCL at this node whose potential is nothing but what? VC, so at that time we will come to know that there are 3 branches which are associated with this VC, right? But as far as this third branch is concerned, carefully just try to see within this branch we don't have any resistive element, right? Directly a 20 volt battery is associated with this branch, right? Means the current flowing through this branch will be what if this is I5 and if this is I6, right? I6, how it is connected? This is nothing but what? VC. This is 20 volt of battery and this is ground node, and current flowing through this branch is nothing but what? I6, right? Now as we don't have any resistive element which is associated with this branch, means here I equals to what here? V by R, am I right? But we don't have any resistive element, so VC equals to what here? This VC equals to minus 20. Here directly we are having the node potential value VC equals to what? Minus 20, because we don't have any resistive element, because this will be our equation number 3. Here no need to apply the Kirchhoff current law at this particular node, because why that KCL is being applied at each and every node in order to determine its node potential. Here directly V2 can determine, as the negative plate is associated towards this VC and positive plate is connected towards the ground, right? When we write the KCL equation for this branch, so at that time we are getting VC, here I will write VC plus 20 equals to 0, means VC equals to minus 20 volt. Directly we can have the desired value of this third node potential, whose name is nothing but what? VC. So what was our objective? Our objective was is to determine current flowing through this which resistor? Current flowing through this 5 ohm of resistor, right? So current flowing through this 5 ohm of resistor can be treated as a I3. So how that I3 is tabulated? By using this equation, I3 equals to either VA minus VB divided by 5 or VB minus VA divided by 5, right? If we consider the first term, right? So in order to determine this I3, we need to solve our equation number 1 and equation number 2, which is written here. Equation number 1 is nothing but what? 7 times of VA minus 2B equals to 1, and equation number 2 is nothing but what? Minus 4 VA plus 10 VB minus 4 VC equals to 0. With the help of that scientific calculator, we need to solve these two equations. So we are having VA and VB. Okay, so before concluding this numerical, again one more time I will share the procedure to tabulate these two node potentials VA and VB with the help of this equation number 1 and equation number 2. But before that, one more thing we need to understand. While declaring this equation number 2, see this is the current equation, VB minus VA divided by 5 plus VB by 20 plus VB minus VC upon 4. So the LCM can be considered as a 20. So at that time here, in that last term, 4 5s are 10, 20. So it is 5 VB, and by mistake, instead of 5 it was written as a 4. So here we need to make small correction. This will be minus 5 VC. Then after that this 20 will get multiplied with this 0. So here instead of minus 4, it will become minus 5, right? So the equation will become minus 4 VA plus 4 plus 1. This is equation number 2. 4 plus 1 5, 5 plus 5 10 plus 10 times of VB minus 4 times of minus 5 times of VC equals to 0. When we solve these two equations, so VA equals to 0.80 volt and VB equals to minus 2.17 volt. So our area of interest is to determine this current flowing through this 5 ohm of resistor. So for that purpose, I5 ohm equals to VA equals to 0.80. This minus will become plus. So plus 2.17 upon 5. So this whole term will give you the current flowing through this 5 ohm of resistor, which is appear in terms of your ampere, right? So this is how the nodal analysis is being used to reduce the number of equations which are to be required in case of mesh analysis or loop analysis. So I just hope you understand all these things regarding this nodal analysis. Thank you. Okay friends, so these are the two equations which we are getting after applying Kirchhoff current law at node number 1. Equation is 7Va minus 2Vb equals to 10, and equation number 2 is minus 4 times of Va plus 10Vb minus 5Vc equals to 0. But as we know from that node number 3 directly, Vc equals to minus 5. So when this Vc is being substituted in that equation number 2, equation number 2 will become what? Minus 4Va plus 10Vb equals to minus 25. Now it's time to solve equation number 1 and equation number 3. Equation number 1 and equation number 3 with the help of this calculator. So for that purpose, initially, first of all, we need to go to that equation mode. As we are having two unknowns with us, Va and Vb, so we need to input all the coefficients of equation number 1 and equation number 3. So the 7Va means the coefficient of Va is 7. So A1 is 7 here. A1 equals to 7. Then B1 equals to minus 2. C1 equals to 10. A2 means coefficient of equation number 3. It is minus 4. Coefficient of Vb is 10. And it is minus 25. So Va equals to 0.80 volt and Vb equals to minus 2.117. So this is how these two values are to be tabulated with the help of this calculator.